Okay, so in today's math lesson, we started talking about prisms and pyramids and nets and comparing these things and cutting things out from paper and building and deciding what types of nets will actually create cubes and things like that. And it was a lot of fun. So, what is a net, by the way? We have this word net, and this is a net, by the way. So a net is a two-dimensional shape or a two-dimensional drawing, right? A two-dimensional drawing that creates a three-dimensional solid. So yes, it's on paper and you can cut it out with a pair of scissors and fold things, use a little bit of tape, and you make a nice little solid. So for me, this guy here would probably be the base, okay? And it would fold along this line, and this would come up and be a side, right? You'd fold that up, and this would be a side also, because that would fold upwards, right? And this would be a side as well. That would fold up. And here would be your other side. That would fold up. And then this guy, he would be my top, right? So if this was the side, that would force this guy to come around on top, and that would be um, my face that's opposing or the opposite face of the base. This would be the base, and this would be the top or the opposing base, right? The base on the other side. And notice they're identical, okay? Which brings us to the whole definition or the whole discussion of prism versus pyramid being defined as this guy over here being a prism, and we'll talk about why, and this guy over here being a pyramid, having one major difference. Both are named for their, so let's put that over here. Both are named for their base. All right, so for the base. So here's the base of this guy, and it's in the shape of a triangle, okay? So this would be a triangular something, and we'll get to that in a second. And this guy's base is this rectangle right here, a square, okay? So this would be my rectangle, okay? And the fact that this is a prism means that the opposing face, okay, the face opposite, there they are, the face that's opposing or the opposite of the base is identical, okay? So they both are named for the base, okay? The prism, okay, the prism has an identical face opposite its base, okay? So here's the face that's opposite the base, this guy being the base, and they're identical. Therefore, it's a prism. I kind of like to think of it as the base holds its shape all the way through the prism. And you'll also notice that the other faces that connect, those two faces are rectangles, okay? And this guy, for the pyramid, you'll notice that opposite the base, everything comes to a point. Okay, so opposite the base, and I should put for a pyramid. All right, so I'll put it over here. So pyramid, okay, opposite the base comes to a point, or a common point, depending on how you want to look at it. So that's what makes a pyramid. And you'll notice the faces on the pyramid that do that connecting or create that connecting are triangles. All right, so we have rectangles over here, and we have triangles over there. And that's basically it. So we have since we have triangles up here for finishing our naming for this prism, we have triangles going through, so we call it a triangular prism, like that. Okay, so that's the name of that guy. And for the rectangle, again, it's named after its base. So it's a for the pyramid, it's named after its base. So it's a rectangle. So this is called a rectangular. Rectangular. Let me get rid of that L. There you go. Rectangular pyramid. Okay, and you can have all kinds of prisms and pyramids. If this particular prism had a base of a rectangle, it would be a rectangular prism. If it had a base of a pentagon, it would be a pentagon prism, and so on. Okay, folks? Well, that's all. That's what we did today. Thanks so much. Take care. Bye-bye.